Today we're going to be finding the average value of a function f of xy, which is z, over a defined region. And the way we're going to do that is to answer this question here. What is the average value of the function z equals f of xy equals 3x add 7y squared over the region described by x between 0 and 1 and y between 0 and x squared? Now let's just have a quick look at that on this 3D graph here, source desmos.com. Thank you very much, Desmos. Okay, so we've got, let's just change colour actually to make it a little bit easier. Let's change to yellow. So we've got the x-axis here, we've got the y-axis here, and we've got the z-axis here. And basically, the region described is between x equals 0 and 1, which is x equals 0 and 1 here. Y equals 0 and x squared, well that is the line y equals x squared. So the green area is the region on which we are going to do our double integration, and the blue bit here is the function z equals 3x add 7y squared. So basically what we're going to do when we do our double integration is over the entirety of the green region we are going to sum the volumes of all of the little cuboids which go delta x, delta y and up by the value of z, delta x, delta y up by the value of z, and we're going to sum all of that up, and that will give us the volume underneath this surface here. And then to find the average value of it, all we're going to do is we're going to find the area of the green bit and divide one by the other, and that will give us the average value. Okay, so let's just go back into into black pen and let's get going. Okay, so basically let's have a look. So what we're going to do here is we need to find the volume. So let's just go back into our xy plane, the more traditional xy plane here, and here's our graph of y equals x squared. So there's y equals x squared, and here is the point 1, 1. And basically if we go down here and let's change colour again just to make it a little bit easier, this is the region over which we are going to integrate. Now there's two ways of integrating. We can either do x first and then y, or y first and then x. So I'll tell you what, let's do in red the x first and then y. So basically if we're going to do x first and then y, so what we need to do, let's go in a different pen again, make it nice and clear. So x first, so basically if y equals x squared, then that means is the same as x equals root y there. And if we go x first, then we're going to start at this point root y, and we're going to go through to 1, and then the y we're going to go all the way from y equals 0 to 1. And so basically if we do xy, then our double integration is going to be the integral between 1 and 0, the integral between 1 and root y of 3x add 7y squared dx dy. Okay, so that would be doing x first and then y. Now if we did it y first and then x, and there's no reason why we can't do it that way, let's have a look. So that means we start here and we go up to there. So that would be the integral between 1 and 0, because x goes from 1 to 0, and the integral between 0 and x squared of 3x add 7y squared. This way would be dy dx. Okay, now both of those will give us the volume, so let's do them both, why not? Okay, so let's do that one first. So the integral between 1 and 0, integral between 1 and root y, so that gives 1 and 0. Let's integrate this bit here with respect to x, and that gives us 3x squared over 2 add 7y squared x between x equals 1 and x equals root y, and we're still going to have to integrate that one afterwards with respect to dy. And so basically let's just simplify that. That is equal to the integral between 1 and 0 of, just putting x equals 1 in and x equals root y, 3 over 2 add 7y squared minus, now put x equals root y in, 3y over 2 minus 7y to the 5 over 2, and we've got to integrate all of that now with respect to y. Okay, and that equals, now integrating the second part of the double integral, that equals 3y over 2 add 7y cubed over 3 minus 3y squared over 4 minus 7y to the 7 over 2 over 7 times 2 between 1 and 0, and that equals 3 over 2 add 7 over 3 minus 3/4 minus 2, which when we put all that over 12 gives us 13 over 12. So basically the volume of the sum of all of these little cuboids here, i.e. the volume underneath the blue surface, is equal to 13 over 12 units. That's using integrating x first and y. Let's just check by going the other way. It's always a good idea to check both, obviously not in an exam, but if we were. So let's integrate the other way. So that would be integral between, so now what we're going to do is we are going to integrate with respect to y first, okay, and that would give us 3xy add 7y cubed over 3 between x squared and 0, and then the answer to that we are still going to have to integrate with respect to x, and that there equals the integral between 1 and 0 of 3x cubed add 7x to the 6 over 3 dx. What I've done is I've just put x squared into the values of y there, and remember this must give us the same answer as 13 over 12, otherwise we have a serious problem. So that equals, now integrating with respect to x, that gives us 3x to the 4 over 4 add 7x to the 7 over 21 between 1 and 0. That's just integrating this bit here, and that gives us 3/4 add 7 over 21, which equals 3/4 add 1/3, which again is 13 over 12. So either way we do it, whether we integrate with respect to y first or with respect to x first, we get 13 over 12 as the volume. Now all we have to do is work out the area of the region. Well, the area of the region is relatively simple. That was y equals x squared here, and we are integrating between 0 and 1, so we need to find the area of this region, and that's just the basic standard integral of x squared dx between 0 and 1, and that is x cubed over 3 between 0 and 1, which is 1/3. So the area is 1/3. We know the volume underneath the surface is 13 over 2, and therefore the average value is equal to 13 over 12 over 1/3, which equals 13 over 4. So if we go back all the way up here, the average value of this function here over this region here is 13 over 4, which we did remember by basically the volume underneath it over the area of the region. Now I hope you found this useful. It's very good practice of double integration and stuff like that, and it's also extremely good fun. If you have found this useful, please like the video and subscribe to the Gresty Academy YouTube channel. Thank you.